Okay. Maybe this is start now. In near the end of last lecture, so we have introduced the package NumPy. The most important feature about NumPy is this capability of allowed support to so-called elements-wise operation. So this capability allows us to express an operation on the elements in the array in a very sustained and clear way. So for example, we want to add two, say, a NumPy array together. Now, if just imagine that you use the basic Python, you need to write a for loop to go through every element. But you just simply just add them together and then you will get the result. Okay. In addition to say adding to array, and then you can do some simple operation, okay, on the whole array. Then it is understood that the result will be applying that operation to individual elements of the array. Okay, so in one shot you get all the results. Why I want to remind this operation is because I'm going to say introduce a very useful application of this elements-wise operation, and to support something that is very powerful to allow us to access important information about, in this case, is an array, which is a two-dimensional array. And now let me, so of course, just imagine that you have a database, and then you want to say access the elements in this database that satisfy some specific condition. So if you have taken a database course, then you know there's a SQL that you can use to select, give the condition on the database, that it will give you back all these elements in the database that satisfy that particular condition. So now in this line, show that, okay, in NumPy supports similar operation. And this, okay, just prepare us to move on next when we talk about pandas working on a, say, a more useful, okay, the structured data frame, and then basically we will just extend this capability, and you will see the reason why we want to explain. Now, here we just simply show to the focus of focus on here. So basically, we have instead here instead of a 1D array, so just make things a little bit interesting on 2D array, but just imagine that 1D array is still the same. Okay, and then we apply the operator, but now it's not the plus and minus arithmetic operator, but it's a relational operator, which is a comparison, smaller than, and then a number. Just imagine that we apply this, make use of the elements-wise operation on the original array. So you can imagine that the operation will be, say, applied, what operation is smaller than 0.5. Operation will apply to each element on this array, okay, and then give you the result in the output. So we can apply 0.5 more than 0.5 on these elements, and 0.35 is indeed smaller than 0.5. So the corresponding output will be true. Yes, the condition is satisfied. For this position, no, because 0.96 is much larger than 0.5. So it is false. So you can imagine that in one single say expression, you get a result with the same shape of the original 2D array, and in which that it will have a true if the corresponding if the operation to the corresponding elements is true. So you can imagine that you want this large collection of data stored in a 2D array or even 3D array. Basically, you want to, from this array, select some elements that satisfy a specific condition. So then the first step is apply that operation to the whole input array. Then you will get a same array of the same shape, and then it will have a true and the corresponding elements that satisfy the condition. So you have this array is called the Boolean array. Okay, so given a condition applied to the input 2D array, that you have a conditional array, which is true false. Now the second one is from this true false so-called conditional array, you can make use of it to select the elements. Okay. Now, how to do the selection? Again, using the index operator, the square bracket. And basically, just like what we have done, that have a square bracket followed by the name of the array and then give the index range for it. But this time it's not the index range, but a conditional array. Okay, so now after this operation, I assign the result to this conditional array. So you see that the shape of this conditional array is identical to the shape of the input A. Okay, so they are of the same shape. Then apply this conditional array of the same shape as A. Then you can imagine that the system will map the conditional array or put it on top of A, and then look at every matching. So if the corresponding elements of A match to a true value in this conditional array, then it will output for you. If the corresponding elements in A, on top of it is a false in the conditional array, then it will filter it out. Okay. So by this true false condition matrix, then put it in back into the original array, then essentially you use the condition to filter out all the elements. Okay, that you don't want that you do not satisfy the condition. Okay, so this is a very useful and kind of essential for data analytics. Okay, so we just want to look at some parts of the data that satisfy condition. Maybe it's not there. Now, the first example is on 2D array, and this is for 1D array. No. Okay, so this is for just instead of have an intermediate step to get the Boolean matrix, Boolean array explicitly, then you can just simply put it, combine the two steps together in one step. Okay, A, the original data, and then get the condition in order to get the Boolean matrix, and then you get the result. Okay, so this is later you will see have similar operation on pandas. Okay, and this is just a preparation. Usually we work on pandas. Now, for the NumPy array, basically we just work on a well-organized collection of numbers. But if you want to do real data analysis, then the input data not only have number, but also may have other kind of type, say character string, or they may have even another list of elements for each entry, so on and so forth. Okay, so NumPy is just working on a specific cases on the data in which all the elements are of the same type. Okay. Now, to work on the real problem, then we will introduce another package. It's called pandas. That the data that it handles, even though conceptually is similar, but it has the necessary extension that will make the data analytics stuff much more realistic. Okay. So let us introduce this package called Pandas. And here, just give you some background on this slide. Okay, basically, this Pandas essentially is building on top of a NumPy array. And you can imagine that you have, like for example, 1D array. For 1D array, that is just a sequence of numbers. And Pandas can allow us to extend it to a similar 1D data structure. We call it series. This series, you can see that is kind of very similar to 1D array, except all the obvious distinction will be every element now you can give it a name. Okay, so this is for series. Okay, and then for 2D array, then an obvious distinction between the Pandas table. So I talk about this is series is one to extend the NumPy 1D array. For 2D array, then we extend it to a so-called data frame. Okay, data frame is nothing but just a ordinary table. Okay, so a 2D array, a table of elements with number of rows and number of columns. Now, Pandas allow us to extend this representation so that we can have name for every column and name for every row. Okay, so basically that this representation is much more meaningful. Instead of a collection of numbers, we really know that what that number are coming from. Okay, for example, if the table is for the assignment, then every column will be the marks of every student on assignment A, assignment 2, and then every row will be associated with the name of the student. So if after adding this extra information is much more useful, because now look at a single entry in this 2D table, then I immediately can know that this is for Chen Diamond's assignment 2 marks. Okay, so this is what we have. And based on this, you will see we can apply those that we have mentioned in NumPy array operation to this data frame. Okay. So before we start, I just want to kind of allude what we really want in a package that supports data analytics. Okay, and in particular, that once we have the capability, then we can apply machine learning tool to it in order to use the tool to do machine learning application. So basically, what we need is, given a collection of data, usually it's a table. Okay. First, we need to associate or create this table in such a way that it is meaningful, contain all the obvious information about the value of this table. So in other words, we want to have name for every row and name for every column. So basically, and as a matter of fact, to look at the package capability that we will see, we will introduce say a function that allow us to say give name to column and name to row. Okay, because this is necessary for this. And after that, then you see we need to kind of take out important information about this table. And so we have different way to do that. Some of the way that you have seen in NumPy will be using, say, the slicing operation on the row, on the column, in order to specify the subset of row and column that we want to extract and focus on. And also, later you will see that you can apply the similar, say, conditional operation to create Boolean matrix and then apply it to filter out those unnecessary rows. Okay, so what we need is essentially is very simple. Okay, factory, I should say, the table, so that it will say have meaningful information about associated with each value. We need to select table column wise and row wise, and we move on to do the filtering to get information. Okay, so this is exactly what we are going to do in the following few slides. And according to say standard run, so we will focus on 1D array first, and then we will go to the array. But basically, we will follow the same thing. Okay, now series is one of the major data structure supported by this package called pandas. So essentially, series is also pandas is based heavily on NumPy. So this series essentially is just a 1D NumPy array. Okay, but pandas just allow us to associate with some meaningful name to every entry in this NumPy array. Okay, so it has a concept, that is about the index label. Okay, but I really don't want to use the index label, just a label, a name for this row. Okay, because like for this that's good concept for every row. Okay, it is associated with an index, and it is associated with a name or label in this case. We'll call it a name. Okay, row has a name and an index. Okay, to avoid confusion. Okay. So in an ordinary NumPy array, then every entry is associated with its index. Okay, 0, 1, 2, 3, 4, 5. Okay, right. But when we extend it to series in pandas, then each entry associated with the usual index, then you can also give a name to that entry. Okay, so let me explain it to you. Okay, so look at this. This is one of the ways to create the series data structure and called the PD pandas. So I forgot to explain it. Okay, I'm gonna show it. So just import pandas as PD. So you check it yourself. Okay, import pandas with PD. Then after you have import pandas, then you can use the function called series to create a series. Now, the argument for this is originally is very simple. It's just you can give it just a list of number, okay, and then it will create a series for you, such that the first number will be entry index 0, second number index 1, and so on and so forth. Okay. Now, if you do not give any other supply any other argument, then the series you see that the index is index. Okay. But now this I just want to make sure that indeed it is not the usual index that we know. It is corresponding to the name of the entry. Now, I'm afraid that is a little confusing, but always remember, explicitly, we can assign a name to a entry. Okay, this is explicit. Okay, and implicitly, the position of the element in the array also implicitly associated with an index. So the index, you do not need to specify. Okay, just look at the array. The first element index 0, the second element index 1, and so on and so forth. Okay, but at the same time, you can also give a specific name to each of the elements. Okay. So here I will jump to this example. So this is the original list of number for the number array, and then we can specify to give a name for each of the elements. Okay, they call it index, but I really a little bit confusing, but just a name. So this, okay, first number is associated with your name Tom, second name Peter, Mary, and Sue. So once you create this series and print it out, that you will have, okay, a series corresponding to this array of numbers, but for every number, it will show the name of that number associated with it. Okay, so Tom, 12, Peter, -4, and so on and so forth. Okay, so obviously, this will be much more informative than just a number array. Okay, now I want to compare this to this. So for this and this, while you see that for this example, I do not have the index equals to blah, blah, blah. I do not provide the name. Okay, so if in the construction, you do not provide the index equals that argument, then by default, pandas will give the name for you, because according to the definition of the constructor, every variable has to have a name. If you do not provide it, okay, then the pandas provide it for you. Then what value it can have? Okay, always the name will be equals to the index. Okay, because it by position, okay, is an index. So if you do not give a meaningful name, then the pandas will use the position as its name. Okay, so this is why when I explain this example, I'm kind of worried that it will be a little bit confusing. Okay, because this is not, okay, the usual index that we are working on. The index basically of element you do not need to specify. Once you have the whole sequence of NumPy, then the position will give you the index. Okay, you do not need to specify. But this one basically is not index, it's a name. Okay, so in other words, in this example, for this number, its index is 0 because it is first position and its name is Tom. For this one, okay, in this example, the first element 12, okay, its index is 0 because it's the first element. Okay, and its name is 0. Why 0? Because you have not kept pandas' name. So basically, pandas use the index as its name. Okay, but what we show here is the name of the elements. Okay, now I understand that this is a little bit confusing, but as a matter of fact, in real application, okay, we seldom just construct it, we will give a name to it. Okay, so but we still need to kind of make it clear the difference between these two concepts, because later when we want to access a particular element, okay, in the data structure, we can use index, we can use name. Okay, so it's a little bit confusing. So I just want to make sure that it is kind of clear everywhere that this concept at the very beginning. Okay, so this just shows you the difference between, okay, the construction using the pandas series and the NumPy array, okay? So this is what you have. And now, in this few slides, basically, it's not that important. It just shows you various ways to create a series. Okay, this just gives you a way to create a series. Okay, using a dictionary in Python. Okay, at the end of the day, basically, if you use the dictionary, you still get the same series. Okay. And this slide just show that once you have created a series in whatever way, okay, and if you display the content, you will see the whole array. Essentially, it's two columns. The first column is for the name, and the second column is for the number array. Okay, but if you just want to see or get the value of this series and just throw away the name, then you can only use the say method applying to the series and the t dot value, then you will get the number array. Okay, so basically summarize, the number array can be extended to series by giving a name to every entry. Okay, and that's various way, okay, to construct it. So you can try it yourself. But I can tell you that this, okay, example is just to give you simple example in order to understand the concept. In real application, nobody create a series in this way because usually the data that we need to handle, okay, more often is hundreds or thousands of values. Okay. So we will not create it one by one. Okay, but this just show you create some simple examples to illustrate the concept. Okay, so this I want you to understand. Okay, now this is why I a little bit worried because you need to understand that we major operation, as I mentioned, that we need to assess some way to assess individual elements. One of the traditional way is use the index. Okay, so this is what we have. So once you define a series here, okay, then you can use the number integer here to get between 0 and the length of the number array minus 1. Okay, one of the index from here, and that use it to get the corresponding element. So for example, this is the series that you type, you get T3. Basically, is in this series access the elements of index 3, and give me the value. 0, 1, index 0, index 1, 2, 3. So the value here. So this corresponding to now. Okay. Now, this use the index to get the element. But at the same time, you can also, for series, okay, you can use the name to access the element. So for this, Su is the name here. So basically, you get it, the main Su, you get now. Okay, so this is the name, and you get the same thing. Okay. Just imagine that you are working on this. Okay, so X. Just imagine that you can access it in two ways. For example, you want to access this element. You can access as bracket and type integer 0. Okay, then index 0, the numbers corresponding it. At the same time, you can also type as bracket and a 0 with 4. Okay, so it's control 0 and 4. Okay, that means that this is a string. So maybe I write that. Yeah, I just want you to at least, so the array, for example, so pandas, okay, dot, okay, and then 1, 2, 3, okay. Then you see that the series will be 0, 10, 12, 30, and then the zeros, index 0 is 10, index 1, okay, is 20, index 2 is 30. Okay, so this is S. Okay, I just want to say, kind of alert you that for this array without giving any explicit name, then I can access as 0, okay, to get this number. Okay, and that, and on this, and that similarly, I can accept this one. Okay, so the first one basically, okay, is used the ordinary index. Okay, while the second one basically is, okay, the name of the index. So make sure you understand the difference. Okay, but it happens that since I did not give the name explicitly, just then pandas will just use the index as its name. But once you give the name, then it is a string, not an integer. And so the difference is here. Okay, so this is the name of the integer. Okay, I hope that is clear enough. Okay, so it's about selection. So this is a very important operation rather than addition. Okay, so now here the second row of example just show that, okay, that instead of one single index, you can give more than one single index. There's a list of index. For this, then you can use the slicing operation to specify the list. Okay, so here 0, 1, 2, not 3, remember. So it's index 0, index 1, and index 2. Okay, so this is a list of numbers. Okay, from 0, 1, 2. But instead of using this automatically generate a sequence of numbers with same spaces of increment, then you can also give the complete list explicitly. Okay, so a list of index 0 and 2, then it will just give you the one that with index 0, 12, and then the one with index 2, 0, 1, 2 is married. Okay, okay. Now, the third row of example here and show you something that can be extended to name. So this row is nothing, okay, as new using index with number. But now you see that it has extended to name. So here I just apply the sliding operation, okay, to this index, but on their name. So this will be a little bit confusing. Okay, so let me explain. So for this one, it will carry the operation following the order of the elements in the array. Okay, so you give them a name Tom and Mary. So we start, okay, to scan the series from top to bottom, and then this is the position for Tom. So we start from here. Okay, Tom, 12. Then it will advance to the next number. Okay, Mary, Peter, and then -4. Okay, until it hit Mary, which is 7. Tom, Peter, and Mary. Okay, so in order to understand it, okay, what will be the output? You need to remind yourself the the picture on the whole array, and then we just look at the entry one by one, find the entry with the name, say it with Tom, and then you just sequentially scan the value until you hit Mary. Okay, so for now, I understand that it's already very late, but for those alert audience here, you will see there's something encountered. What is that? For sliding operation, we all know that according to the traditional convention of Python, specify in this way, then the ending and the right end of the sliding operation will never be included in the output. So even though you type 0 to 3, so the index 3 elements will not be included in the output. Okay, it is used to specify the end, but the end will not be included. Okay, so it's 0, 1, 2, 3 is not it. But if you use the sliding operation to the name, then the right end will be included. Tom, Peter, and Mary. Okay? So I kind of really suspect that, okay, this is some kind of protest for the ordinary programmer, that why have this kind of unnatural convention is you specify the range, and the last one will not be included. Okay. So when they just implement, okay, the program as the designer or vendor, but when they implement this one, it just insists that, okay, if you use name, then it will include the line. Okay, because it's so obvious, so I don't understand why the designer of painting, okay, that make this obvious kind of inconsistency on using this kind of example. But anyway, it's just a digression. So basically, just I just need want to alert you that it's a little bit more careful. Okay, and but other than that, for the using the list of name objects, okay, just look at the name in the list and then find the element in the name. Okay, so this basically show a very important step that allow us to select the elements, okay, by either this index and by this name. Okay, from 51. And for series is essentially it's just a number array with name associated with every value. So obviously the say elements wise operation, okay, that applied to ordinary number array can be applied to series. Okay, so instead of an ordinary number array, so you have a series here, then plus 2. That this plus 2 will automatically apply to every value in the array, in the series. Okay, and also not so this is the additional operation, and this is for the division operation, and you can even apply some system defined function to the apply with the series. So np dot square and then the series p, then you will see that every element will the argument for the square in order to get the result. So 12 square minus 4 square and so on and so forth. Okay. Now I just want to make this or make a little bit alert to you is that this kind of applying a function to a series such that that function will apply to each value of this series. This is not applicable to all functions. Okay, yes, it is applicable to a function supported by NumPy, such as this square or square root, if you still remember, and all are log and that kind of function. Okay, so if you apply the function increment by or support provided by NumPy NP, then that function can be used to apply this kind of annualized operation. Just one single function name applied to the series, then this function will apply to each individual element in the series and get a whole new array. But this is not applicable to all functions. Okay? As a matter of fact, if you write your own function, try to apply it. Okay. So if you define a function, the input is an individual integer, then when we call this function, but instead say use a series as the argument, then you get an element. Okay. So, but I can tell you that if you really want to do a similar thing, then there's another so-called function called apply that you can use it. Okay, but this is kind of all about script here. Okay, but anyway, just kind of a warning to you. Okay, so for all this standard arithmetic operation, the elements-wise operation, okay, is can be applicable. Don't worry. But if you want to apply a function, use this elements-wise operation and then apply a function. So every element is the element. Okay, then it's not okay applicable for every function, but I can tell you that for those functions, increment and apply. Okay, but it is not that important because if you really write a program and encounter this, and then you will find out okay that function cannot use to apply this elements to us. Okay, and again you can use apply the conditional relational operator to this series, and they will give you a kind of a conditional array, and this conditional array put in with the square bracket, then you can do the filtering operation. Okay, that's what we have discussed for NumPy array. So this essentially carry everything from NumPy array, except that you can give a meaningful name to every value, and then you can select okay the value by those names. Okay, so this is only visual. Okay, and here for every series, basically it's also applicable for NumPy. I don't know whether we have explained it. Okay, introduce it as a NumPy. Anyway, NumPy can also be applied to function. Okay. So given the series, this is the value. Okay, then you can find the maximum, minimum by okay the name of the series dot and then the maximum. Okay, is 3. Minimum is 0. The sum, okay, sum of it basically is 9. 5, 4, you get 9, so it's sum. And the mean that is the average is 1.5. Okay, and this function is a little bit special here because it returns you a NumPy array. Okay, but what are they? Basically, these are the value in this NumPy array are the value in the original array. Okay, but it just lists every value once, even though it appears more than once in the original array. So you just tell you what is uniquely the entry. So for example, in this original input as you have 2, 1 here, but if you call f dot unique, that it will see 1 okay, in the output of call, so then it will see it 1. Okay, but another term will be 0. So basically, just look at it, you just know immediately the total number of values that the same value that this will obtain. Okay, now here may not be that useful, but just imagine that you have this array, okay, 1,000 people, okay, that is students studying in Hong Kong, so we have thousands of students, and they are corresponding to their age. So you have an array here, okay, then you want to know, okay, so the age of the student. Okay. So basically, for example, for 20 for high school, 15, say for example, then you see that the whole array has a lot of 15. So basically, a lot of extra information. Then you just use unique, then you will see there's a okay, student from 15, 16, 17, and so on. Okay, this is unique. And now for this is for the value show the unique to you. And for this one is a little bit okay, this value count. This value count is to show all the unique value as its name. And but then the entry will be the total number of occurrence of that value in the list. Okay, so here the output is a series. So this is the name, okay, and this is the value. So the name corresponding to the okay, so that okay in the series S, there's an entry value 1. How many of them? 1, 2. Another name 2. Okay, it also appears twice, so the value count is 2, and that there's a entry value 0 appears 1 and 3 appears 1. Okay, that but a little bit say interesting here. They are not sorted on the name, and they are not also do not follow the value of the entry. So I would suppose it's 1 first, and then 0 second, and then so on. So now instead of 1, 0, then we have 1, 2, 0. I don't know how they invert, but anyway, they just show if using this value count, you can immediately see in this array for every value how many occurrence of this value in the series. Okay, so is it clear? Good. Now we have say kind of show you okay, all the necessary operations that work on series. That is access from index, use condition to filter out the value, so on and so forth. Okay, but obviously a series is not that common entity for the analysis. It's because the most commonly used the data structure in data analytics is a table. Okay, for example, you just collect the data and store it in an Excel file, then that Excel file will come out itself in the table. Okay, so table basically is kind of the most popular data structure that is used to data analytics. And since it is so popular, so this pandas explicitly allow us to construct a table, handle that, okay, by various functions, by pandas. But they do, pandas does not call them table, they call them data frame. Okay. Now I'm a computer science. I really don't know what is the difference. Okay, but it's simple. That in pandas is called data frame table, but in the language R, that you know that as I mentioned, that's 2 cat. Okay, for language R, they also call table is data frame. Okay, so this data frame may be a very commonly used word in data analytics, you know. Okay, but data frame is the first time that I come teach with pandas. Okay, package. Okay, but anyways, table is the most popular data structure that how to create a table. Okay. So this is what we have. But essentially, for table, just imagine that a data frame or a table is just a concatenate of many series together, where the series is of the same name. Okay, but this series consists of the columns of this table. So given the table, then it is divided into columns, where each column you will check it yourself that the column indeed is a series type. Okay, but anyway, so if a table is consists of columns, that many columns consists of rows. Okay, so row and column. So essentially, it's a 2D array. Okay, row and column. Okay. Again, the extension of 2D array to table is nothing more than just allow us to give a name to column and a name to row. Okay, so this is just a upgrade for us to handle this set of values using more informative way. Not just the position, but also we have the name. But then you can imagine that just like series. So now every value in a table, okay, is specified the row and column. And now you can imagine that, say, for row, basically it can be specified by its index, that is position. Row with index 0, row with index 1, and so on and so forth. And also it can be addressed by the name of row. Okay, this row is for Chen Taiman. So you have this one. And that, so it's very similar to a series, but extended to data frame, then you can see that it can apply it to column. So you can use the index column, use the index to access the column, and you can use the name of the column to access it. Okay, so basically it's the same, but extended to column. Okay, so let us see how to do that. Okay, now to create, now this one basically is not no use. Yeah, it's actually for you. You will not handle a table with only a true row. Okay, it just shows you how to create a simple example. Okay, so that you can see the operation. Okay, so how to create an example using one way is using dictionary. Okay, such that for example, it has 3 columns, then the dictionary has 3 key value pair here. Okay, and then the key specify the name of the column, and then the value will be a list corresponding to the value in this column. So this is the column color, this is for column object, this is for column class. Okay, so make sure that all the columns have the same name. If not, then you see that there is some funny value to say to insert in order to make the name to same name. But anyway, make sure when you create the same name. Okay, that if you create this way, then the name of the column, okay, kind of already handle it for you. Okay, so you can access it by the index of the column. Okay, so index 0, index 1, index 2, and also using the name index. Okay, but if you create in this way, then the row, okay, do not have any name, so it will use the index as its name. Okay, so here is not the index, here is the name. Just it happens that the name equals to the index. Okay, so this is string. Okay, now and now this is creation. This is now later you will see that The data that we handle usually are collected manually from some survey, and then this data will be stored in a large Excel file that contains, say, thousands of rows with, say, dozens of columns. Okay. So there are some standard functions that allow us to read this Excel file into our pandas program using pandas so that it will create a corresponding data frame. But a usual immediate operation after your reading of the complicated table is to kind of throw away all the unnecessary data or rows so that you can focus your attention to something important. Okay, so basically, usually we will just read the data, then we'll throw away all the unnecessary rows and filter out some problematic. Throw away, okay, the unnecessary column and filter out all the problematic rows. Okay, so this is the standard operation. And here is important because it shows you how to select it. Right? Okay, so just imagine that you have dozens of columns. Okay, but you find that the column object applied is what you want, then you just type column into the object and write. Then this function 2d.data frame given dictionary, it will just throw away the column that is not listed in this argument and just give you the table with the column. Right? That is specified here. Right? So it's selecting the column. And here gives you give the label of the rows one by one. So basically, it's just an extension of series, nothing more. Okay, and this is also combine them together that you can do giving the index name for the row as well as selecting the column. Okay, so we find okay. So you read it as well. So this is another example of creating a data frame, but now the input is not a dictionary, but instead it is a 2D array. So remember, I use NumPy to create a sequence of values from 0 to 15, increment by 1 after each value. Basically, we have a 16 value here from 0 to 15. I will reshape it and while we shape it as a 2D array, 0, 1, 2, 3, 4, and so on. So this is essentially a 2D array. Then I can just using this index and column to give a name, okay, to the row and a name to the column. So the first index row 0 have a name brand, index row 1, 2, and so on. At the same time, the column index 0 will get a 4, column index 1 for 0. So it's quite obvious, okay? But anyway, it is not common for us, okay? Because we never handle this small table of data frame, okay? And here give you a list of three data frame. I'll leave it to you to look at how to do that. Okay. So here is some useful information for us to get the basic information about data frame. Okay. So here, when you create a data frame, it's called frame. Then you can use this .column function to get what is the name of the columns, how many of them. You can also get the index operation to get the name of the index. So if the index is some meaningful individual name, then you will see the name here one by one. but it happens that, for example, here, the index essentially is a sequence from 0 to 4. So instead of put at least 0, 1, 2, 3, 4, it just gives you this one. Okay, to tell you that this is the sequence. Okay, and this gives you the value of the data frame. Okay, so it gives you the first row, second row, third row, and so on. Okay, so it's really awesome. Okay, so now here shows you that you can apply to the function that remember the series basically they have I can that function sum, mean, max to the series. Right? The series is one series of values, so you can find mean, max, sum, produce output. Okay, now in this line, just show you that this sum, mean, max operation can be extended to a data frame. Okay. Now, this extension, if you think about it a little bit more careful, then you will find immediately you should ask two questions. The first question is if the data frame column is not numbered, instead it's just the entry is a say ordinary string, apple, orange, for example. Okay, then how can we use sum it? Okay, and second, this sum, okay, the range or the domain that it applies. So you have a lot of columns here, a lot of rows, right? Are you summing up all the values, or are you summing up part of them, or are you doing one single sum operation, or are you doing say more than one sum operation? Okay, so for data frame, okay, immediately bring out a lot of questions. But anyway, this is what we need to know. Basically, the operation are column-wise. That means that for sum, it will do the sum for every column and give you the result of that column. Okay, and instead of giving you the sum operation for every column, it will only apply those columns that contain number or value. Okay, so for this call, okay, it's 4, pen, pencil. Then when you call sum, you will not get any value. Mean, not sum. Okay, mean. Then you will not get any result from that. So for you call the data frame dot mean, then you will not get result from color. Okay, because it is meaningless to find what is the mean of this color. Okay, the object so you will not. But it happens that for sum, it just concatenate all the values together for this say non-numerical number. So concatenate blue, green, yellow, red, white, blue, green, yellow, red, white. So I don't think it's meaningful, but this is what is usually. Okay, but for the column numbers, and they give you a meaningful sum. Okay. Similarly, it can work on max and min. Okay, so but you see that even for character string, we can compare it, okay, using the so-called dictionary order. Okay, so just imagine that you want to compare two words. Then you just imagine that if you use a ordinary dictionary to find the word, you will say find which one you use. Okay, so for example, find the maximum. Okay, so here for this value, okay, blue will be much earlier than G, and then red and W and then Y. Y, okay, will be much larger than all the other values. So maximum is yellow. Okay, and for this one it's pencil and so on and so forth. But anyway, so the key point is the operation for data frame is column one. Okay, so it's not the whole set that is involved in the operation. Okay, each column is a series, so it's each series per column with a prime. Okay, it's about operation. Okay, and secondly is not all the columns will give you the result. For some column that is not numeric, then sometimes it's not meaningful to get the result. So it just give it. Okay, so this is what we get. Okay, and this is the median. Again, the function, and this example that shows you how to rearrange, okay, the row in a data frame by calling the sort function, the sort value. But we have a lot of free columns here, so you need to specify what column that you want to focus on the sorting or price. Then we focus on price. Rearrange the row, but the whole row, but according to the value in price column. So now the smallest row is 0.6. So this the whole row will be the first row of the resulting data frame. The second is 0.9. So just this is the second row and so on. So, okay, so this is kind of the expression here.
Sorry for the reaction.
Yeah.
So why the median function only get the middle value of the price? The color and the objects.
Median is pushed to the cliff.
Yeah, I know, but the result only get the middle value of the price. And
No,
there is
so,
color and
you know, it's not mean. It's mean. The minimum, first quantile, second quantile, third quantile, and maximum. Median is just the.
Yeah, I know, but it's sort of at a price, but why there is no the color and the object object price 1.0.
Object price. So this one.
Yeah, the green and the 10. And the 1.0 is one side, and we use the function median. Okay, and
yeah, so maybe this one is easier to look at, right?
Yeah.
Okay, so this is the minimum. Maximum.
Yeah, the side 1.0 is the median.
Yeah, right.
Yeah, but when we use the median function, it only show the price, and there is no green and return. Why don't we show
not showing this one? This column?
No. I mean the green, the 10 and 1.0 is a side, right?
Okay, so let me not. We are patient. Okay, so first, what do you want me to focus on in this slide? So this one, or this one? This one. Okay, focus on this one. And then the output is price 1.0.
Yes.
Okay. So now for this one, I think I agree that it is correct.
Yes.
Okay. Then what I perceive the problem is why we do not have an entry for object and entry for category.
Yes.
Yeah. Okay. So I don't know. Because we just think that is meaningless.
Okay.
Yeah. But just imagine that a look of color. Sometimes if you also work on language art, you will have to very say at least for us working on ordinary computer programming for that sometimes the thinking is a little bit difficult to forge. Just like this, okay. Sometimes they think that it's important and improves. Sometimes it's not. So what's happening? Why are you doing this way? But maybe this is what they value, okay, in the community. Because sometimes for at least I'm just teaching, not really the teaching. So sometimes it's kind of not in a position to really understand the real operation and what is the start. As a matter of fact, if you read those textbooks, okay, on data analytics, in the introduction, then they always say that the most important thing of the data scientist fact of this data analytics. So what differentiate good data analytics and bad data analytics is they develop a good stuff in order to say kind of process the data in the best ways. So this is kind of like a book, but this is what the textbook said. Anyway, for me, okay, sometimes I really don't understand why they are doing that way. Okay. Okay. Now, here, okay. So again, so we come to the question that how to assess the row and how to assess the column. Okay. Now we have a problem here. Now, of course, assess the row or assess the column, we need to give the index. But given the index, it can be a row index and it can be a column index. How to differentiate? Now, kind of give us different ways, but for us, we don't need to learn all of the way. Okay, so one way is to use the differentiation, okay, by calling I index or ordinary column index. Okay, so if it is for a row index, then we will specify before the the square root operator and type is I location ILOC. Okay, ILOC corresponding to row index. So again, why don't we call it row? We call ILOC. We don't know why. Okay, but this is for row index, and that gives the index 0, 1, 2. So it's okay, index 0, index 1, and index 2. So we get this row. Okay. Again, you can also the row index. Then we can use the slicing operator to get the index 0, 1, 2, not 3. So it's 0, index 0, index 1, index 2. So you see that this is for the row index. Okay, not the name of the row, index of the row. Okay, and you will try yourself. Okay, that if you move I and then you get the column. Okay, so this is what we have. Yeah, I think we take a 15 minutes break here, and then we will complete our discussion on this, and then we can move on machine learning.
Yeah, some problem when you go small. Yeah, I got ongoing. I check the I found what is the error. And you assess the data from using the URL. Mm. Zero. Train matrix. Now it's not your program's problem. Oh, yeah, it is the implementation. So when what is so let me do. You have to see your work. You just want to do when it get wrong. So with this one, this one fits. Then you have already do the model. Yes. The type of extreme just give. So what is extreme in my tree? You see that string. Okay. You have this NAN. But I try to drop now, but this error still happens. Yeah. Now I would suggest you this way. Okay. So create an X string and Y string. I just include 2 or 3 rows. What? 2 or 3 data points. 2 or 3. Yeah. So how large is the data set? So how many lines there? Yeah. So it's too large. It's too large. Not too large than column. Just want to say simplify the training data set to make sure it works first. Don't work on the complete data set. Yeah, the full data set. Okay. And after you just say pick 1 or 2 rows, okay, and then train it and feed it to see if you have get simple error message. So if it still cannot work for this small data set, that means that the function itself may have problem. Yeah. If this is not, that means that it works for small data set, but does not work for such a large data set. That's my data problem. Because this is so large, you do not know what is indeed all this content. So maybe there's some will cause you trouble. I really don't know. So in order to figure it out, you just work on some many data set that you have a clear idea what is where, and then try to apply the same program to it. If it works, the data set has problem. If it still doesn't work, that means that when you call the model, then it's problem. But that is not your problem. It's the models. It is the implementation problem. Now, usually, this is not uncommon because if you understand this, all this package are built on some earlier package. For example, write this say package. I need to call those functions from NumPy and so on. Okay, so basically, when they implement their program, they call some function. Okay, provided by NumPy, say for example. Now, during the course of evolution, NumPy as a new version, and then but this basically, if the designer
implementation, the developer of this program does not catch enough to make the update. So I have always had this problem. So I teach this course for 4 semesters already. So every semester, some of the program cannot run. So I have to Google and find, okay, what kind of, say, changes that then I need to say make the changes. For example, change the version or change the code and so on and so forth. Okay, so it's not uncommon because the field keep on changing their package, and another one is most package is depending on some other package. So if they have a new version and then it did not update fast enough, then but don't worry. Okay, in the industry, once it's problem, then basically the Stack Overflow and that kind of thing, they will discuss it. Eventually, it will say get back to the developer and know the code.
Actually, it's my in charge of and predict the stock.
So what was the input? So many say
It's the volatility of the history. This is back 21 days, 34 days.
relativity. Wow, this number is huge. E to power 10.
You can. It's from actual.
Doesn't make sense for me.
So it's from.
What data does it?
It's from.
Okay. So
That's stock.
So this is the market cap.
Yeah. It's
Yeah, we should understand. Okay.
I understand.
Yeah.
I'll try.
Yeah. So basically, this is for what? For your project.
For it's my intern.
Intern.
Yeah.
Okay. Yeah.
Thank you.
Okay, no problem.
We have another idea about the sliding biology. Because I think when we use the labels, we must include the last one.
Yeah.
And in the number, the index is just be -1, but now in this case, the exact labels. Yeah, right. I think it's not.
Just kidding. Just kidding. Okay. So what's your view about that?
So I just think that maybe
It's meaningful.
this is not meaningful. I think, yes, it's very meaningful because
Yeah, I'm just kidding. Don't take it too seriously. Basically, how to say? For me, it's kind of a right way to do that. And this one is kind of, I don't understand why the convention is going on. But there must be some reason for them, but anyway, I don't know.
this is item.
Yeah, yeah, yeah,
That's all.
okay.
Thank you.
Must be more than 150. Basically, I don't mind, but I do not have the authority. You still need to go to the embassy office. And then you may be, you can tell them you have put in mind. But it is possible that when the class is full up, even though it cannot say a classroom can accommodate all the students, also have to stop.
I see a lot of students are still available, but
Because then we will You skip the class. Okay. Yeah. So you maybe to go to the MSc office. Okay, I've already extended some new students enrolled. Okay, because I don't want. But the problem is there's some other constraint. So it cannot be extended.
So I just want to ask whether if there are seats available or the abstract of the course will be.
I really do not have the ability to do it.
The example on how to create a data frame are not for real. Okay, it's just a hard problem. Okay, so create some data frames so that I can show how to do it. Okay, so in real data analytics, no one will create the data frame manually. Okay, so usually they will kind of import the data from some standard, say, data formats stored in your computer. Okay. And then read those standard files and then into your program and convert it into the data frame. So this is a most commonly used way to import data. And for the data format, basically, they have different kind of data format. The most commonly used data format is store, okay, the data in a text file, okay, using the simplest to say, Windows Notepad, whatever. So just a ordinary simplest data file, text file, in which, say, the first row will contain the content of the first value, first row, and second line will be the second row data, and so on and so forth. Okay, but you need to tell the system that the value, okay, so in special character for specify value, separate value in each thing, in each line of the text. Okay, so basically they are called, okay, the what kind of separated value, and usually it have a so-called comma separated value, or sometimes if you can use a tab, sometimes you use a special character, but usually use a comma. Okay, so maybe I can show it to you. Open it. Hey. Okay, so for example, the format will be something like the number, say, 10, and then comma 12, comma 304, and so on, and then Peter, comma 25, and then and so on and so forth.
So basically, this is the first row and this is the second row. Every row has 3 values and then they are separated by comma. Okay, and then of course after that, then you can store this. Okay, save this file. Okay, so say this file test. Okay, but the content usually, okay, is called comma separate value. Okay, and it's the file, and then this is what we have here. Okay, so this is the format that we mentioned here, CSV. Okay, basically it's just a text box. Okay, and every line will be a row, separate value are separate. Okay, and of course we have our the good friend Excel file. Okay, and we can also input a table, which I've never used it, but you can check it. Okay, so this is for reading special file from outside the program and then read the data in and then store it with a data frame. And also you can export your data frame and write your data frame into a graph in this kind of format. Okay, so you can try it yourself. Okay, so let me give you maybe I'll do it later. So this gives you an example on reading an Excel file. So in order to do that, so you have to import pandas and PD as usual, and then you just call, now since this is an Excel file, so you call the function provided by pandas, it's called read underscore Excel. So this is for Excel file. If you, as I see, if this is a ordinary text file separated by comma separate value, then you can call it read CSV. So depending on the format, then you have various different functions for you to read the data. Okay. So if this is an Excel file, then you call it. Then after that, then this function will create a data frame that contains the value identical to those that store in this Excel file. This is the input. Okay, but I just want to digress a little bit because in this data set, which is a real data set obtained from on some site in Europe interested. Okay, and for those sites, then basically this is a real data set, and for real data set, that's a very common scenario here is when there are many entries in the data set are missing. Okay, and just kind of remind you that to handle this kind of data set, be a little bit more careful. Okay, that check convention, you can check it in the website that the missing value will be represented by some special character. Okay, so this in this data set, we said that for those missing value, okay, it is replaced by a code. So for this kind of data, value, then you know that they are missing and demand. And okay, for this kind of data, there's many ways to handle it. Okay, sometimes you just delete the whole row. Okay, of course we cannot delete the whole column, then we just delete almost all of it. So delete that particular row or replace it by a value, say 1, 2, 3, whatever, or replace by the mean of all the other meaningful values in the row and so on and so forth. So basically, if you take a data science course, doing a couple, basically that's simple functions to do this kind of thing. Anyway, I just want to alert you that when we handle data, even for this course in machine learning, in finance, and different things. Okay, so when we handle the new set of data, usually we need to be a little bit worried about the missing value. Okay, as a matter of fact, when we talk about the fault detection,
that we will show you how to handle this kind of situation. Okay, so this is what. Okay. So let us say leave it after later. Okay. Okay, so that is what we want to say. Now, there's something for this program. Basically, if you it's already sufficient, okay, to read the data set. Okay, but since we are working on Colab, the Colab, the way to execute it is they execute everything, okay, on their server, which is not on your local computer, but everything is executed on the server. So the program itself will be stored in the working directory of the server in the Google site. Okay. Now, usually we do not have any problem about it because the whole program is in server. Okay, and then the program will call, say, TensorFlow, Keras, and that kind of thing. Okay, and then it will load the necessary function package from the internet. Okay, no problem. But if you have your local data file to work on, then there's a problem. It's because that data file, of course, cannot be accessed through internet. Okay, of course you can store it in your local server and then give the link to the program. You can do that, but anyway, just if you just want to say access the local file from the server in the Google site, then there will be a little bit problem. Okay, because the server side cannot access it. So basically, in order to run your program using Colab, now if your program is stored in your local computer under say Anaconda, then you do not need to handle it. Okay, this for an extra step to handle it. But if you use Colab, then there's some extra step. Basically, you need to upload the program in your local computer to the working directory in the server. Let me repeat. So if you run your program using Colab, which is executed on the server in the Google site, basically you need to do one extra step, namely to upload the file that's stored in your local computer to the working directory in the Google server. Okay, so one extra step. Once this file copy into the working directory, then you just execute it and then it will execute normally because the program and this file are both in the working directory. Okay, but still you need to do an extra step to upload the file in the working directory. How to do that? Okay, so this is one way to do that. Forget about this too complicated. Okay, so maybe I need to revise this. Okay, because I don't need to work in that same detail. But anyway, I'm sure you how to do that. Okay, so basically is I need to import a file, okay, called files, okay, from the Google Colab, and then based on this file, I can do an upload to kind of choose a local file to upload into the working directory. So let me show you how to do that.
So basically, I'm asking to install kind of import the files of the library provided by Google Colab. Okay, then I can just call Colab. Okay. Okay, so now I just explain this step. So when you execute this step, then you will see in the Colab, say, Jupyter Notebook will ask you to choose a file. Then that means that you can choose a file, type it in your local computer. Okay, so maybe I find the file that I need. Basically, is teaching this 7024. Okay, lecture notes, first lecture notes. Okay, for this file. So I just upload this file. Okay, and then it will have the file. Then what is the effect? Basically, effect is it will read or upload your file, this name, okay, into your working directory of the Google server. Okay, and then so after this executing it, then you will say you can imagine that your working directory in the Google server basically contain the same file with the same name. Okay, then after that, then you can easily call. Okay. Okay, please read Excel. Excel as Excel. Our name. Okay, the same file name. Okay, so what is this? EDUCUOEFINE06.XLS. Okay. Okay, so let's see. So you will read all of the data file. Okay, so what I want to explain it is so in general, you do not need to execute this step if your data file are in the same local directory, then you execute the program. But if you are executing this program on Colab, which is in the working directory, not in your local computer, but in the Google server, then you need to upload your local file, the data file, to the working directory. And this is exactly what you can do. File upload. And then you will, when you execute it, then we will have a browser ask you to choose file, and then you have the boxes for you to go through all the necessary folder to find the file, click it, and then you can upload the file. So after this step, and this is the file that I choose, then this originally is in my local computer, but when we choose it and then execute it, then the same file will be uploaded to the working directory of your local computer. And then since the program and your local file are the same working directory, then it will execute it normally. Okay, so you need this extra step. Okay. Then after say you call read Excel, on this file, then the content of that Excel file, will be converted into a data frame. So this is the data frame that we will see. Okay, so this is what we have. Okay, so this is what I want to say. Okay, so maybe we have enough discussion on pandas. Basically, I give you necessary background. But don't worry, when we go through the example of this course, showing you various programs for building machine model for various finance problems, and whenever we need to get back to the discussion here, then basically I will explain it, and that is very easy to remind yourself. Okay, so basically we have enough background for pandas. Okay, so now let us go to machine learning basic. Okay, so for this course, so two major components that we need in order to proceed with the real discussion. First, of course, the basic tools to handle data, and then second is the basic step for doing machine learning. Okay, so don't expect I can go very deep into machine learning. I'll just give you the overall step that generally need to follow in order to do machine learning. So first, in order to understand machine learning and at least understand why in recent, let's say, years, machine learning has become so popular, powerful, such a hot topic, while our traditional programming language are almost 30 years, suddenly it seems that lost its power. Okay, so I just want to explain it a little bit. Okay, so over the last 5 or 6 decades, the major way that we use computer to solve our problem is to write program using some existing programming language. So basically, the way to do that would be something like this. You have a problem. Then you formulate this problem into some concrete, algorithmic problem. Okay, and then you design an algorithm. So if you take data called a data structure and algorithm, that means you design an algorithm to solve the problem, specify all the necessary steps in order to lead you to the solution. Then once you have a clear and detailed enough machine learning algorithm, then you use a programming language to implement this algorithm. Okay, either you can use C, you can use C++, and blah, blah, blah. Okay, and then you run the program. Okay. Now,
for machine learning, basically, what you can do is to build a machine learning model, okay, to solve your problem. So it will basically you have a data, and then you have a machine learning model building algorithm to use the data to train a machine learning model. I'll give you more detail later, but this is the general picture. And this machine learning model is your program. And you can use it to, okay, read new data input and then get the result for this data input. Okay, so instead of writing design the algorithm writing program, then you just use data to train this data model. Okay, eventually you have, after that you have the same thing. Okay, give input to the program, you have the result. Give input to this data model, you have the result. Okay. Okay, so this is what we have. So given this is the model building algorithm. Immediately we will show you what it is, give you an example. But the way to apply machine learning to solve your problem is you prepare the data and then feed this data into the machine model building algorithm, and this algorithm or this program will output a so-called model for you, and using this model, and then you can give any input based on this model, which suggests, okay, what is the output. So this is the program essentially, that in our traditional sense. So, but basically it's not you to write this program, but some existing model building algorithm to write this program for you. But how this model building algorithm know how to write the program is you give enough data to train, okay, for training his model. Okay, so this is the high level idea. This gives you an example. Okay, now here this is an example called linear regression of model building algorithm. Okay. So what is this? Now this is the most simple example here. So what is linear regression? Basically, maybe we simplify the discussion, assume that all the data points are on the 2D plane, okay, on the 2D plane. And of course, you do not know all the possible data points in the 2D plane. So you get some example of the data, okay, the data. Okay, then the model here as linear regression is to say determine a line on the 2D plane that is the closest, okay, to every point. Okay, so basically what really you have done is to, okay, given the data point, then you run a linear regression model building algorithm. This algorithm basically is to look at the data point and then find out the straight line, okay, that is closest to all the data points. I'll explain in a minute what we mean by closer, but this is more or less what we want, okay, closer to every point. So this red line is the model in this example. Now, based on this model, then you can use it to solve your problem. Okay, what is the problem? Okay, given any input, okay, then you just go and this is input A, then you just find, okay, on this line, what is the corresponding y? Okay, and this is the output of the input A. Okay, so basically, let me summarize it. So what is the data? The data basically is pointed to the plane. Given the input, okay, X, then you have the output Y, F is 0. Okay, input X 0 and Y 0, X1 and Y1. So this is the data point telling the general linear regression model building algorithm that given any X in this data point, what should be the output Y? So this is all the point here. Then the model building algorithm will give you, okay, the way to, okay, a line that closest to every point. Okay. So this is the program essentially that allows you to, for any input, find out the output. But how to do that? So you given an X, you want to know Y. So given an X, you want to know Y. So what is the Y? Basically, the Y is the, okay, point, XY point on this line. Okay, so why the Y will be a reasonable solution is because we expect that all these, say, points are kind of follow the same trend. And this same trend are, say, correctly estimated by this model line. And for this model line, basically the output will be even for other X that is not in the training data set, but they are, since they are close to this line, and then the value will be more or less the same. Okay, so this is the basic idea. Now, this slide, now you at least get the basic idea. So now this line basically is tell you why machine learning becomes so useful to, so important. Okay. Basically, you will already say feel it when you say go through the example that we cover in this course. Basically, in the old days, you have a large, say, company, say, banking or whatever, that you want to use computer to solve your own problem. Okay, so you need to hire a group of programmers, and the programmer will look at your problem, and then they try to design an algorithm, and then implement the algorithm using a programming language and get a program. Now, this is very important. So basically, different organizations need programmer to write program to solve their problem. Now, the quality of the programmer are of utmost importance to the success of the computer software. Okay. So as a matter of fact, for the same problem, if it is written by an average programmer and by a super programmer, and then the program that written by the super programmer will run, okay, almost, okay, shorten the time for by half, okay, than the one written by average programmer. So basically, the success of a computer program depending very much on the quality of the programmer. If you use the standard traditional program approach, okay, so basically you will find that only a small number of organizations that have enough, say, capability to take out and hire the best programmer, and they are the winners. All the others are average company that the program is more or less full of bugs and cannot run. Okay, so this is why it's so difficult to implement good programming software. So for this traditional programming approach, not everyone will be very successful. But now, we now have another model to solve a problem, which is called machine learning model. It's just a name. Basically, it's an algorithm to build a model, again, based on model to solve your problem. Okay. Now, for this one, all organizations, okay, can use the same model building algorithm. It's not the tradition. Okay, there are different organizations. You have this problem more or less have something different, then we need to design the new program for it. But here, okay, all problem can be solved by building the same linear regression model. Okay, so no matter what is the problem facing by different organizations, very powerful organization or some less powerful organization. Okay. All they need to do, they have a problem. All they need to do is collect their own training data, then they run this linear model algorithm to build the model. Okay, the same problem in building linear model algorithm. Okay, so now basically the research community have a kind of a group of super programmers. Okay, they are so nice that they implement this linear programming model building algorithm. Okay. And then they make it for free, put it in the open source, and let everyone can use it. So now the situation is totally different. You don't need to be a super programmer. As a matter of fact, like many of us, you don't need to be have a good experience in programming, because the important point is someone who is a super programmer, they have spent the time and effort to implement kind of the best program for solving this linear regression model building out. And then take it for free and then access very easily through the internet. Okay, so under this model, everyone now is a super programmer. Okay, so basically all we need to do is write a program, prepare our data, but this data, our input data, is a variable, it's our problem. This is what we want to solve. Okay, so this one basically, we'll assume that we already have that, and then we make use of the best program, to build the best model to solve our problem. So certainly not in the traditional model that only a few companies have enough resource to have a team of super programmers to write the best program for it, and therefore other average companies that the programs that they have written and full of bug and very slow and that kind of thing. Okay, but in this new model, everyone can access the best program from the internet. All you need to fit in the data and then get the model made. Okay, so now it becomes kind of much easier for us to write software to solve our problem. Later you will see in a minute that, not in a minute, but maybe next week, that we don't need to really know how to write the program. All we need is to know the API, import the software, know the API, call the program correctly by inserting the correct training data. Bingo, you have already the model. Okay, so this is why machine learning
okay, become so hard. One of the reasons is this. Okay. So now let us talk about machine learning. Okay. Because there are different kind of problem. Okay, for machine learning. Basically, we can divide machine learning into three groups, at least for beginner, because over the years, the last few years, there's a lot of different class of supervised machine learning. But anyway, for us, okay, just focus on three because this is what we will cover. The first is called the unsupervised learning. The second one is called supervised learning. The last one is reinforcement learning. So you will see, okay, different example on this kind of learning in this course. For now, let me focus on first on the supervised learning. Basically, supervised learning works as follows. For example, you want to say, this is a kind of a stupid example everyone uses. So, if you want to teach your child what is an apple and what is an orange. So basically, the usual way is to give the child lot of example of apples and lot of example of orange. Okay, and give it to the child and then let him learn which is an apple and which is orange. But however, we just give them apple and orange, no use, because the child do not know the object is just with them, whether it is an apple or orange, not because it have no information. So in order to help your child, basically, for each object, then you will tell the child that this object is an orange and this object is an apple. Okay, so this is kind of a supervised learning. Basically, is give object for the little child to learn, but not just give them the object. You will help it. Supervise his learning by for every object tell him or her that this is an apple, this is an orange. So in other words, this supervising learning, the data set will be, training data set will be the set of objects that in your domain, but then for every object, you have to label it with the suggested answer. Once you have this data set, then the machine learning building model algorithm basically will read the object, assess its data characteristic, and then based on this characteristic, you know that having this characteristic, it should be an apple. Do it for the next object and so on and so forth, accumulate the information, and then use a model to summarize the information such that whatever object, then it can tell whether it is an apple or an orange. Okay, so this is called supervised learning. And this kind of learning have application, in our case, is fraud detection. So for fraud detection, for example, in a bank, so basically, in order to design a system to detect, say, problematic, say, bank transactions, say, for example, to detect, say, money laundering, basically, it just like the apple and orange, give them all the transaction with different, say, characteristics of different measure, and then for each transaction, we will tell whether this transaction correspond frauded and not transactions are not frauded. Okay, so this is a supervised learning. Give the data set
let the model learn from the characteristic, and then the model answer to build a model that can tell, okay, decide whether a transaction is a fraud transaction or not. Okay. Another example is image classification. Okay. You can recognize a cat and dog, for example. And another supervising is regression, and we have seen machine learning. So this is supervised learning. Another kind of learning is unsupervised learning. Unsupervised learning basically is you solve the problem by, okay, just give the example without telling them, okay, what this example is about. So, for example, giving a group of movie go kind of a customer, say for example, and then you want to find out, okay, this group of customer, okay, which of them prefer Nike and which of them prefer say Adidas and so on and so forth. Okay, or not or maybe they have similar tastes. Okay, so basically this unsupervised learning basically depending on the similar behavior of each object, and then you group the object together into different groups and get the information about it. Okay, so this is called unsupervised learning. I'll give you an example in a minute. Okay, the last one is called reinforcement learning. Okay, for reinforcement learning, am I? No. Okay, so basically later you will see how to use reinforcement learning to do arithmetic training. Okay, so later you see the example here, but maybe we will say leave it at that moment to give you more information about reinforcement learning. But it is not that easy to explain it without a complete sum. Okay, so this is what at least 10 years ago, okay, this is the standard type. But now there's a lot of new type of machine learning. Okay, but there's no way to talk about it. Now, let's go through some examples to give you more idea on supervised learning. Okay. Now, this example is on supervised learning, and then I'll give you example on supervised learning. Okay. Now, for this example, basically is to what is the problem? The problem is a data set that gives you the object, and then you will need to build a model to decide whether the object is an apple or is a fruit. Okay, and in the object, of course, it has a lot of characteristics or features. So now we will just, okay, in this example, focus on two features: the color of the object and the shape of the object. Okay, the color can be red, yellow, and green, and the shape can be small round, big oval, or big round, or triangle, whatever. Okay, so this is the possible features of the object, and then for this feature, I have to tell in the training data set, okay, what is this object? This for those object with red color and small round shape, it should be an apple, and so on and so forth. So this is the suggest solution, and this is the input. After this, it will train a model such that later when we give whatever type of input, it will tell us what should be the label. Okay, so based on this training data set, it will find a machine learning model building algorithm to build a model to help us to distinguish what is an apple and what is a pear. Okay. So this is one application. This is another application for supervised learning. So here is for classification. Okay. Now here is for predicting the output of a function. Okay. So I've showed you already. So that is the more concrete example. Suppose that we want to design a machine learning model to predict the number of ice cream cells, the number of cones, okay, that we can store every day, okay, depending on the temperature. Okay, for example, when the temperature is 12, then we will sell only 5 ice cream cones. Like this, for example, okay, so if we were serious about that. And then 24 the ice cream cones. 50, for example. So in general, we believe that the higher the temperature, the largest number of cones. Okay, so now we want to build a machine learning model based on supervised learning. Why supervised? Because the input is temperature, while output is the number of ice cream cone cells. And in our data set, we need to account for a particular temperature, the number of cones that have been stored on the day with temperature set. So this is the royal answer, output, the P of the apple. And now it's the number we for. Okay, 12, temperature, and then this is 5, and so on and so forth. Okay, so this is supervised learning because the input is then the label 1. Okay, so this is supervised learning. Then for linear regression, basically is a standard statistic method that given a set of data points, then you do a hyperplane. In this case, it's a straight line on the 3D plane that is closer to every point. Okay, so this line I can tell you that is closer to every point. So this is the model that we turned by this linear regression model. Okay, this line. And when we have this, say, model building, then what should we do? Okay, then we will just, for example, 30, the temperature 30. I don't know what is the number of ice cream cones, but then based on this model, then I just find the point on this red line with x equals to 30, and then I just kind of figure out what is the corresponding y coordinate of this point. It's kind of 90. So basically 90. Okay, so this is what we have. Okay, give the input together with the suggest solution for that input, and then give it to the model building algorithm that it will build a straight line closer to every point. And this straight line is the program for us. Program to work fast. Okay, so this time forget about it too much. So this I just want to show you what we mean the closest. Okay, maybe I just give you a very important. So the closest maybe the vertical difference between the sum of the vertical difference, absolute value between the line as well as the point. So the deviation from this point on this line is this portion, and the deviation from this line and this point is we just sum up all the absolute value of this difference, and then want to make a line that minimizes this is kind of a normal definition here to minimize the number of errors in order to find that line. Okay, but unfortunately, this absolute value is kind of very difficult to handle in mathematics because it's not continuous, so you cannot apply calculus. Okay, so instead of using this until that the linear regression is just make this limited by this function. Okay, this is easier to handle because they are all continuous function. Okay, but you don't need to know that. Okay, I'm a little bit. Any question?
Okay. My energy level is dropping very quickly. So what happened? Now, this is another example of machine learning, but a different class. It's called customer. Now, for customer, basically, give you an example and then we will understand what it means. So, in this example, we will say have a data set. Now, it's not supervised learning, so this data set does not have model answer. But this data set will, okay, contain, okay, the opinion of 9 users or movie goer, okay, 9 users. And then we will ask each user give us the rating of movie A and movie B. Okay, that's showing that rating 9 means that the user liked it very much, while movie 1, that means that they do not like it at all. Okay, so this is the moving A and moving rate of movie B. Okay, and if you draw this rating on the 2D lines, this is what you see. Okay, there's 3 users. Okay, that will be very small rating of movie A and movie B. While there's another 3 users that have a high rating on movie 1. Okay, it's movie B. Okay, and moderate rating of movie A. While this one is also a very high rating on movie A and small rating on movie B. Okay, so basically, for example, movie A is a romantic movie type. Movie B is a kind of an action movie. And you will see that this group corresponding to the user that do not like to go to the movie anymore. Okay, and for this one, then it like action movie, and this one is like kind of what is movie, romantic movie, and so on. Okay, so basically, in this, we kind of already get the idea is that given a set of this kind of data, basically, it will kind of the distribution will be followed by the case of the user, and different but the group of user is not infinite. Okay, they will be a kind of a small group of user. For some group, they are all like a whole movie, or they do not like any movie at all. So basically, the position of the pawn, for those positions that are grouped together, that it will have strong indication that this group of users have similar behavior. So this is called cluster in the sense that from the position of the data, that we can group those data into a number of small number of distinct groups, so that we can find the characteristic of this user. Make sure that for those that have the similar taste are in the same group. Okay, so this is for unsupervised learning. Okay, and just imagine that given this data, then go through the cluster learning model building algorithm. Basically, it will have this kind of model. Then it is the case that every point in this region will be in group 1, point in the region is group 2, deploying this region is free. Okay, so what we get is now that we know kind of okay the user in this group with this behavior, with this group with this behavior. Then whenever we have a new customer, okay, then we will find to which region that this new customer belongs. Okay, and then based on similar taste of the user in this group, then we can recommend advertisement. Okay, so this is what the recommendation system of application is. That is, given a large set of customers, then we give survey to those customers. Okay, and then based on this survey, then we will find a model to separate the user in different groups, and then based on the group or the user on this group, then we can find out what is the taste on that group. Okay, and then every time we have a new customer, then we can, based on the model of this customer learning algorithm, it is in this group, and in this group we find that most of the user in this group say like action movie, say for example. Then for this new customer, then we send a lot of advertisement for the new action movie. Okay, so this is what the recommendation system are built based on this customer. Okay, so this is kind of very important application. Okay, in our customer recommendation. Okay, so unfortunately we do not have time to cover it. But maybe next time I will throw out one topic and then add it to my topic. Yes. Anyway, this is the podcast stage. I keep on watching my work. Okay. I have also here is give basically the explain what is reinforcement learning. Okay. So later in this, we will explain an example called Q-learning. Okay, which is kind of a rigid algorithm for reinforcement learning. But anyway, it just gives you an idea. So reinforcement learning basically is to let the child, or sometimes it's called an agent, that we want to train by giving him reward or punishment for every action that this agent takes, so that eventually it will kind of learn which actions can lead to reward and which action will lead to punishment. Okay, so if you on this kind of a large number of say reward or punishment cycle, then it will know what to do, in order to get that reward. So eventually the picture will be like this. And entity or component to describe in reinforcement learning will be the environment and the agent. So this agent is the reinforcement learning model. Okay, and then whenever initially the agent will say get the state of the environment. Okay, and then for example, we know that what is the position of the chess? Okay, it's the state, and then it decides to take action. Okay, and then the environment will, based on this action, decide whether this action is a nice move or a bad move, and then it will kind of give a reward and feedback to the agent, so the agent knows that whether the move is good or not, and then of course after this action, the position of the chess will be updated, and then it give back to the agent. And then this agent will analysis, and see what should be the next action. And that from that time to time, remember, every stage that action
it will learn how to say play chess, more students. Okay, so this is for reinforcement learning. So this gives you an overview on different kind of machine learning. And in this picture, basically is to show you of the standard step for carry out a machine learning application. And as a matter of fact, you will see in our example is basically follow this kind of step. For some application, okay, one or two steps are very important and we spend more time on it, while the other application will focus on the other step. Okay, and it will show you basically the 5 steps. I will go through it first very quickly, and then we will go through each step in more detail. So, one of the major difficulty in solve a problem nicely using machine learning is you can get enough data. Okay. So remember, we don't now need to worry about the programming part because the best program is all already available on the internet, so we can get it. So not about the program. So the most important part is for the gathering the data. As a matter of fact, there's some papers saying that, okay, well, all they have, say, study all the machine learning application, they find that the more than 70% of the resource will be used to gather the data, cleaning the data, so on. So the data basically is become now the most important step. Okay, so you need to have the right data, large enough data in order to build a general enough and accurate model. Okay, get the data, then you need to do the data preparation. Now, for different applications, and this step will be different. If you use and want to build a machine learning model for stock price prediction, then basically the data preparation is kind of easy. You use some, say, platform to get the stock price automatically. Now, the stock price basically is just a record of the price of that stock on that particular day. So basically, it's very simple, it's just a value. Okay, so it is kind of easy to handle this kind of data. As a matter of fact, you don't need to say kind of clearing the data or revise the data. No, that's really handle. But on the other hand, if you look at the application on, say, fraud detection, basically you get the data from the transaction from the bank. Okay, and that data set will be huge, and since it is handled by, say, human in order to get the data, then of course, then you have a lot of, say, problem or missing value in this data set. And also, that you need to say, because you want to kind of keep all the important information that contained in this data set, but then there's a lot of, say, useless information. For example, in this large transaction, large collection of transactions, and you want to detect the money laundering. Okay, so most of the transactions will be normal transaction, while only a small portion will be for money laundering. So when you handle the data, then you should be very careful. Okay, so it is kind of depending on application, the data preparation that will be very important. Once you have the data preparation, then you have the correct data for training, then you can apply the machine learning building algorithm to build the model. And
later, when we talk about machine learning building model algorithm, we will go to some existing website that collect all the advanced machine learning building model algorithm. Okay, and it is kind of not that surprising is you will find that existing, okay, different machine learning model building algorithms is not that much. It's about 56. Okay, so all they have been implemented by the best programmers for this 15 or 16 different model building algorithms. So all what we need to do is look at our problem, our data set, and pick one that should be most suitable, okay, for to build a model for them. Okay, but for us, basically, you just pick some, say, commonly used. Okay, what is commonly used? So it's random forest, linear regression, export, that kind of thing. Okay, for search, so-called the traditional, say, model building, and if you want to have deep learning, then use TensorFlow to build a neural network. Okay, so there's not too many choices for us. Okay, for us. But if you want to really have an application that is up to the standard, then in that case, you need to have a deeper understanding on the implementation of different, say, machine learning model building method. Okay, read paper to see what the strength and weakness. So that this step is in fact very important, is based on your application and your data, pick the best one. But for us, pick anyone will enough, okay, for education. You have the model, and then you need to test it, and then after that you evaluate the result. And if it is not good, then you just train it again until you get the best result. And eventually you want to have the model to see. Okay, but for the testing and testing result, basically you need to be very careful to make sure that the training will not be overfitted with data. This is one of the very important. Okay, I will explain you how to do that in a little, but I can tell you that 10 years ago, when the machine learning became, say, a hot topic, okay, so in our department, many students decided to work on, say, the final year project with machine learning to do the fraud architecture. Okay, that I go to many of their presentations, all of them will just claim that my machine learning model, okay, the prediction is okay compared to other standard statistical model. You see, my model is much more accurate than the other method. Okay, see how good I am. Okay, but yes, that the result basically show that the model will have a very accurate result on the training data. Because the model is so powerful that it can adjust the parameter so that for any training data, we have very good result. Okay, but then we ask them to try the model to some data that is not in the training data. Okay, then we find that all the results are unbelievably poor. Okay, the main reason is that we at that moment we do not realize this so-called overfitting, and the model is so powerful, so that it just makes the model fit the data of the training data, okay, very accurately, but we just sacrifice the generality that apply this model to other, say, data. So basically, this overfitting now everyone knows it's one of the most important, say, problem that we need to be aware, okay, for any machine learning application. But we'll talk about it, okay, later. Okay, 45. I did not say go early. Okay, even though I'm very tired. Okay, well, this is all for today. Okay, just remind you, okay, try your best to form the group and start, okay, to find the property for. Okay, thanks. Good.
他到一讲啊，